This is AP Physics question 35. The free fall acceleration on Mars is 3.7 meters per second squared. For part A, we're going to be finding the length of the pendulum with the period of 1 second on Earth and Mars. And for part B, we're going to find the mass of the unknown object that's suspended from a spring. To find the length of pendulum, we're going to be using this formula, the period of a pendulum. T equals 2 pi times square root of length divided by acceleration. We know that the acceleration on Earth is 9.8 meters per second squared, and the period is 1 second. So plug everything in, and then you should get 1 second equals to 2 pi times square root of length divided by 9.8 meters per second squared. If you simplify it all, then you should get that the length of the pendulum on Earth is 0.25 meters. For the length of pendulum on Mars, we are given that the acceleration is 3.7 meters per second squared, and then the period is same as the one on Earth, which is 1 second. And the formula should be 1 second equals to 2 pi times square root of length divided by 3.7 meters per second squared. And then again, simplify everything, and then you should get that the length of the pendulum on Mars is 0.09 meters. For part B, we have an unknown mass that's suspended from a spring, and then that spring has a spring constant of 10 newtons per meter. We're going to be using the period of a mass this time, period of a mass on a spring, which is similar to the period of a pendulum, but then replace the length with mass, and then replace acceleration with the spring constant. So it should look like 1 second equals 2 pi times square root of the mass divided by this 10 newtons per meter. And then simplify everything, and then you should get that the mass equals to 0.25 kilograms.